I'm going to solve the 1992 question 6 from College Board AP Chemistry for your response question. This is a buffer question, and A asks, from the systems above, identify the conjugate pair that has best for preparing a buffer with the pH of 7.2. For pH, at equivalence point, pH will equal the pKa. And as they give you the Ka, if we take the negative log of each Ka, we're going to get the pKa, which also equals the pH. So for number 1, the negative log of 4.2 times 10 to the negative 7th is negative 7th is 6.3, 6.38. For the second one, the negative log of 6.2 times 10 to the negative 8th is 7.2. So the phosphoric acid will be best for the buffer with a 7.2. So H2PO4 negative will best create a buffer. With its conjugate pair. Okay. That's what I wrote. B says, explain briefly how you would prepare the buffer solution described in A with the conjugate pair you have chosen. So since we chose phosphoric acid, we're going to have to dissolve. In order to create a buffer, buffers equal amounts. Equal amounts of the salts will have to be dissolved. As amounts, I mean amounts are in moles, so you have to have equal amounts of moles dissolved of both H2PO4 negative and H2PO4 negative 2, which is phosphoric acid. Question C asks, if the conjugate of both acid and conjugate base have chosen were doubled, how would the pH be affected? Explain how the capacity of the buffer is affected by this change in concentrations of acid and base. So since in order to find the pH, we can use the Henderson-Hakelbach equation. In that equation, it's the salt over acid ratio, and this ratio is both going to be doubled, so it's not going to change. So neither will the pH. So pH will not be affected. the capacity will just double. Of each ion prepared. Question D. Explain briefly how you prepare buffer solution in A if you had available the solid salt of only one member of the conjugate pair solutions and a strong acid or a strong base. You would need, for this question, you would need 1 mole of either the salt of either of the pairs of the conjugate. And depending on which one you have available, you need a 1/2 mole of either the base or the acid, depending on the conjugate you chosen. The H2PO4 negative will have to be paired with the base, or the HPO4 negative 2 is with acid. And by combining the 1 mole and the 1/2 mole, you can create a buffer. With only 1 salt of the pair and 1 strong acid or base. Okay, sorry. That is my answer. And that is question 6 of 1992.